understand how all this works, we should start at the bottom, the Zeroth law of thermodynamics. Now, this law focuses on temperature and defines thermal equilibrium. In general, an equilibrium is where certain properties like pressure, volume, or temperature remain the same across the system. So if two or more things are in thermal equilibrium, then they're all at the same temperature. The Zeroth law says that when two objects are individually in thermal equilibrium with a third object, then they are also in equilibrium with each other. This is important because when a body is left in a medium at a different temperature, energy will be transferred until a thermal equilibrium is established. That's why if you leave a cold soda out in the sun, it will warm up and reach the same temperature as the air outside. The basic ideas behind why this happens lie within the next law, the first law of thermodynamics. The first law of thermodynamics applies the law of conservation that we learned a few episodes ago to thermodynamics. It basically defines heat as a form of energy, which means it can neither be created nor destroyed. So we can't create or destroy energy, but we can convert it from one form to another. This might seem pretty simple, but it's a powerful idea. Now, no matter what system you're looking at, there are two areas of energy that we need to concern ourselves with: the energy contained within the system and the energy that can move between boundaries. Let's start with the energy inside a system. We can break it down into three main parts. The first is kinetic energy. This is the type of energy that's involved with movement. The most common form is translational kinetic energy, which is when something moves from one location to another. There's also rotational kinetic energy, when something spins or rotates, and vibrational kinetic energy, when something shakes or vibrates. The second type of energy inside a system is potential energy. This is energy that can come from where something is, even if it's not moving. We can basically think of it as stored energy. But the third type of energy that we'll find in a system is a bit different. It's called internal energy. Internal energy is the energy associated with the seemingly random movement of molecules. It's similar to kinetic or potential energy, but on a much smaller microscopic scale. Take a glass of water, for example. As it just sits there on the table, the water doesn't seem to be moving. But on a microscopic level, the water is teeming with molecules that are travelling around at super high speeds. While this type of energy might not seem as important, it can have major effects on a system. All these types of energy, kinetic, potential, and internal, show us what can exist within a system. But these types of energy can't cross the boundary from their system to the surroundings. But we've already talked about the main types of energy that can cross boundaries. One is heat, which we know to be the flow of thermal energy, and another is work, which is essentially any type of energy other than heat. So knowing all of these different types of energy involved with a system can help us understand the first law of thermodynamics. Let's start with a closed system, where no fluid is moving in or out. The first law of thermodynamics states that the change in internal energy, kinetic energy, and potential energy of a system is equal to the heat added to the system minus the work done by the system. This equation may look pretty complicated, but there are a few different scenarios that can help clear it up. One is the stationary system. If you look at the left side of the equation, you'll see that the changes in kinetic and potential energies will be zero for a system that isn't moving. Crash Course Engineering is produced in association with PBS Digital Studios. You can head over to their channel to check out a playlist of their amazing shows like Braincraft, Global Weirding with Catherine Hayhoe, and Hot Mess. Crash Course is a Complexly production, and this episode was filmed in the Dr. Cheryl C. Kinney studio with the help of these wonderful people, and our amazing graphics team is Thought Cafe.